In this video, we're going to continue rewriting literal expressions, and we'll begin by rewriting complex fractions. Now, a complex fraction has fractions within fractions. For instance, here our numerator is 2/3 p and our denominator is 4, or 4/1. So we have a quotient, but the numerator of the quotient has itself a quotient. So our goal is, in this case, for instance, to rewrite this original quotient as this final product. And here would be the steps I would take. First, I would think of this denominator as 4/1. Now recall that when you're dividing a fraction by a fraction, the idea is to take the reciprocal of the denominator and multiply it to the numerator. I now have three factors, 2/3 times p times a fourth, and you can multiply in any order, and I choose this order. That gives me 2/12 times p, and of course I can reduce that to 1/6. Try simplifying this rational expression to this form. First, I'd think of a as a/1, and I'd rewrite this back to the idea that multiplying that by a half can be thought of as dividing by 2. Now, since I have a fraction divided by a fraction, I take the reciprocal of the denominator and multiply. When you multiply fractions, you don't need a common denominator. You simply multiply the tops, which I would write in the form 2 times a, and multiply the bottoms and get b. Try this one. Notice how you should end. Well, I've already got a fraction divided by a fraction, so I would multiply the numerator by the reciprocal of the denominator. Notice now that I have a factor of a in the numerator, that is, this is a times 1 minus h, and I have a factor of a in the denominator. I can reduce the factors of a, leaving 1 minus h over h. Notice, though, I'm still not to my final form. To get there, I'm going to have to use the technique from the last video and rewrite the fraction. H divided by h is simply a 1. And now I finally do have the form I'm after. Try this one. One way of finishing this would be to multiply the numerator by the reciprocal of the denominator. Now I could distribute and get 2 times a and 2 times b. The factors of 2 can now reduce to a factor of 1, and I have my final form. Try this one. Notice the final form that you're after. After thinking of h as h/1, I would multiply the numerator by the reciprocal of the denominator. Now I can't reduce the h's here because this is part of a difference. That's also why I can't reduce the 2's here. So the best I can do is multiply the numerators and multiply the denominators. Now I'll shift into the technique from the previous video where we split up our fractions. The factors of 2 can now be reduced because they're factors. They're part of a product, and the same with the factors of h. Both of those will reduce to factors of 1. And now to finally get to my final form, I have to think of division by 2 as multiplication by a half, and then I can rewrite it as the product. So that was a little work with rewriting complex fractions. The last technique we're going to work on to rewrite literal expressions is using negative exponents. As an example, if we had this form, we might want to go after this form. One way to do that would be to move the d squared into the numerator and change the sign of the exponent. I put a 1 down here to make the point that this is all part of the numerator. Then the last thing would be to see this as just 4 over 1 and multiply the numerators and the denominators together. Try rewriting this expression into this form. First, I'd use the technique from earlier and write two fractions. Notice the factors of r can reduce to a 1. Last, I can move this r to the first up into the numerator as long as I make the exponent a negative. Here's another. Keep in mind, this exponent is only affecting the base of k, not the 2. If you wanted to affect both, you would have needed parentheses. That means the base of k will move to the numerator and the exponent will go to positive 1. Of course, we usually don't write exponents of 1, and the 4 and the 2 can reduce to 2. Try this one. Please notice the final form that you're after. After rewriting our fractions, we can reduce this b squared to a factor of 1. And then last, we can move this base of b to the numerator and make the exponent negative. And here's the last one. After rewriting our fractions, we could reduce the common factors of 2, reduce the common factors of pi, and reduce one factor of r. Looking at the form I'm after here, I notice that I need to move this base of r to the numerator and give it an exponent of negative 1. Last, I can rewrite division by 2 pi as multiplication by 1 over 2 pi. And I don't really need the parentheses. Well, that was some practice with rewriting using negative exponents, and that concludes our videos on working with literal expressions.